Although the computer in front of you or the mobile phone in your hand may appear to be very smart, the reality is that your computer is nothing more than bits of plastic, metal, and silicon that can follow instructions very well. All the applications that you've installed, from your favorite music playing application to your web browser, merely are programs that follow a predefined set of steps. Of course, there are many times when you get to make choices along the way, such as picking which songs to play or visiting certain websites, but each program has only a limited number of things it can do. Complex applications like your web browser perform a variety of functions, display web pages, play music and movies, and so forth. However, for each of these sub-functions, say rendering all of the HTML that a server sends to a browser, can be accomplished in many different ways. And depending on the set of instructions or algorithm that is used, the way in which the desired outcome is achieved may be different. So an algorithm is just a set of instructions that all your computer program follows, just to do something. Just like when you're baking a cake, you follow a recipe step by step. Let's say that I want to write an algorithm for how I get to work in the morning. Clearly, each one has the same beginning, me at home, and has the same ending, me at work. But there are many different ways in which I can accomplish the same task of getting from home to work. For example, let's talk about algorithm 1, which is walking. Well, step 1 is I walk out the front door, lock it, I walk 3 miles, and then I enter the office building. Algorithm 2, we'll call this one riding the bike. Step 1, I walk out the front door and unlock it, and I unlock my bicycle, put on my helmet, and ride 3 miles. I lock up my bicycle, take off my helmet, and enter the office building. Algorithm 3, which is the bus, well, I walk out the front door and lock it again, I walk half a mile to the bus stop, I ride the bus, and then I walk the short distance from the bus stop to the office, and I enter the office building. Algorithm 4, I call the taxi company, I walk out the front door and lock it, get in the taxi and ride the 3 miles, and then I enter the office building. As you can see, each of these methods does the same thing, gets me from home to work. Naturally, however, one wonders which one is best. Clearly, if there's one algorithm that is superior to all others, I should always choose that one, right? Unfortunately, as will often be the case, each of them has its own pros and cons. For example, we can look at the cost of each of these alternatives. Walking is obviously the cheapest, while taking a taxi is the most expensive. So if I just cared about spending as little money as possible, I would always walk. On the other hand, if I evaluated these based on how long it takes me to get to work, then walking would be the slowest alternative. In this case, taking a taxi is probably the best option. These same sorts of trade-offs are made in actual computer programs. For example, if you want to search for an item in a list, there are several ways to accomplish this task. But depending on the initial state of the list, the number of items, the amount of memory you'll need to use, etc., there are different algorithms that will be optimal in different situations. This is why it is important to know not only that there is an algorithm that can accomplish the task you want to do, but also how it does it and what its strengths and weaknesses are. Otherwise, you might be in the unfortunate situation where you decide to take the walk to the office algorithm when you have to be there in 15 minutes. Not exactly the best choice if your boss is waiting for you at the meeting. My name is Patrick Schmid, and this is CS50.